Hi everyone, today we're going to be talking about topic 4.6, Introduction to Titrations. Before we start talking about all the types of titrations and what you can use it for, I wanted to give a little bit of a description of the setup. And so this piece of glassware here, which we use for titrations, is known as a burette. Sometimes you'll be seeing it spelled like that, sometimes it's spelled like this right here, but that's the burette. This, of course, is our Erlenmeyer flask. The liquid there, the solution that's in our burette, this is known as the titrant, and this is at a known concentration and volume. Down here we have the analyte. This is our unknown at an unknown concentration. And so what this can be used for is to determine the concentration of an unknown substance based on its type of reactivity. And I'll show you what I mean by that in the next slide. Now, in a titration, typically the titrant reacts with an indicator in the analyte to indicate when a chemical reaction is done. And so what you'll do is you'll have these little, dissolved indicator, and you'll drip in some of this titrant solution into your analyte, and normally it's done with a change in physical property. Normally this can be color, but can also be a change of state. Now, there are three main types of titrations that we're really going to be considering here. The first is acid-base titration, and this is really the most common. It can tell you how much acid, it can tell you the concentration of an acid or a base based on that neutralization reaction happening. So this is based on neutralization. The second is a redox titration, and this indicates a change in oxidation state, which again we will talk a lot more about in a later topic. And the third is a precipitation titration, and this indicates a change of state, right? Well, it's indicated by a change of state, right? You have a precipitate formed in a precipitation titration. Now, there's a few bits of important information and data that you need to record. So data needed. One is the molarity or concentration of the titrant. As a reminder, what's in the burette is the titrant. So you need the molarity or the concentration of that. You need the initial volume, which I'll often denote as V with a little subscript I, of the titrant. That's important. You need the final volume, which I will typically denote as V with a subscript F, of the titrant. And you need the volume or the mass of your analyte. And again, the analyte is what we have in the flask. And so the way we can tell a titration is actually finished is by what's known as the equivalence point. So the equivalence point is when all of the moles of analyte are used up by the titrant. And so what we have here is known as the titration curve. And so it's a titration of a strong acid. This would be a form of acid-base titration, where you have an acid as your analyte and a base as your titrant. And what you record is the pH. And in an acid-base titration, we're looking for neutralization, or when the pH is 7, right? So it's the pH of water. So that reaction is complete. So what'll happen is you'll see this slowly starts increasing as we get to 10 milliliters. 15 milliliters, the pH is slowly, steadily increasing. Suddenly we have this really big jump right here. And at that point is when we see the neutralization. That's when you know the titration is done. What we can do is we can record the volume of NaOH required from that. And so from the volume of NaOH and the molarity of NaOH, right, because this is your titrant, you know both of those things, you should be able to calculate the number of moles. And because you know the number of moles there, and you know your chemical reaction, you should be able to calculate the number of moles of analyte. So there's a few basic steps really of any titration. Step 1 is to add titrant of known volume and concentration to the burette. Step 2 is to add a known volume of analyte to the Erlenmeyer flask. Step 3, and this is sometimes optional, depending on what kind of titration we're looking at, but is to add an indicator. If you're doing acid-base, for example, you would add an indicator to your analyte, and this would change colors once the titration is done. So again, this changes colors. Step 4 is to slowly add titrant to analyte until the reaction occurs or stops. Number 5, record volume of titrant added. And number 6, calculate number of moles of titrant. And then finally, using the balanced chemical equation, we can calculate moles of analyte. So if you always follow these steps here, we should be able to calculate the number of moles of analyte using a titration. We'll have a little bit of practice doing this in some practice problems in class, but for now, that's all. Thanks, guys.